everybody! I am so glad that you are here and you're joining us for our first ever episode of our GSCM STEM Month series. I'm really excited that you guys are tuning in to learn a little bit more about STEM and all the amazing things that we have for you this month. I hope you learn something new and maybe get excited about STEM in a new and different way. Now, starting off today, we're going to be talking about a topic that I absolutely love, so I hope you guys get excited about it too. I love our planet, and one of the coolest things about our planet is that we have so many different types of ecosystems. Now, an ecosystem is an area that contains all different sorts of things, both living and non-living. So it contains things like birds, animals, reptiles, snakes, plants, and also things like soil, rocks, and water. So things that might not be living. Now we have two kind of major areas, or two kind of major categories of ecosystems. We have terrestrial ecosystems and aquatic ecosystems. Terrestrial ecosystems are places on land. So anything from a deciduous forest or a desert ecosystem to all the way down to our aquatic ecosystems, which deal with all different kinds of places that animals under the water might live. Now, what we're going to be especially looking at today is one very unique area called a shoreline. Now, a shoreline, as I'm sure a lot of you know, being out to the beaches of Maryland, is a place where we have the land meeting the sea. Again, being from Maryland, we also know that everyone here loves to be near the water. We have great things to do and great places to go, and so over time people have built up structures and we've built up houses that are right on the water. Unfortunately though, Mother Nature being what she is and doing what she does, the water actually over time erodes our shoreline. So if we have our houses and our buildings, one thing we're having to be conscious of as humans is the fact that we need to protect our homes and our buildings from erosion. In some cases, what we've done is we've put up a wall. It's sometimes known as a seawall, which can be made of concrete or wood panels with a lot of hard-packed earth behind it to prevent this erosion. Now, the Girl Scouts of Central Maryland is doing something a little bit different to protect our shoreline. What we're doing is we're creating something called a living shoreline, where, as you can see behind me, we're planting native plants along the shoreline where our terrestrial ecosystem meets our aquatic, in hopes that this plant life will kind of develop its roots and really reinforce the structure of the shoreline. This is not only going to make sure that the water in and around our shoreline is healthy and is able to promote lots of life and different kinds of animals, but it's also promoting a home for our terrestrial animals as well. Living shorelines are a great example of how we can get just a big community of animals thriving in one small area. In 2014, we were very lucky at the Girl Scouts of Central Maryland to be granted our bond bill from the state of Maryland, which allowed us to continue our development of our living shoreline at our camp facility at Camp Whippoorwill. It's an amazing project, and girls can actually play an active role in creating our living shoreline. That's right, you and your troop can come out and help us to protect our planet right here at our own campsites. Now, as I mentioned before, a living shoreline is really important. One, because it does provide a new community and a new area for lots of animals to live in, but also because it helps to actually make our water a little bit cleaner and healthier. So it provides a lot of natural filtration for our water that flows right over here. So what we're actually going to do today is we're going to see how healthy our water is. And we can test how healthy water is in a lot of different ways. So the first test that we're going to do to check to see how clean and healthy our water is actually testing the pH, as I mentioned before. Now, testing pH is testing something that tells you how much, again, if you have a more acidic water or if you have more basic water. We don't need to get into what those terms quite mean in detail, but just know that acidic water isn't the best for humans to be drinking, and therefore probably not good for fish and aquatic life either. So what we've done is we've gathered 4 different samples of water. We actually have one sample from the Baltimore City, just regular drinking water. We have one sample from a nearby pond source. We have a third from our, actually right here from the waterfront. And then fourth, we have an anonymous bottle of bottled water. So all different areas that we've gathered this water from, and what we're going to do is we're going to again test to see what the pH is. So when we're testing pH, what we use is this little strip right here. And all you need to do is you take this strip and make sure you submerge all of the 4 different pads into the water. Now, all of these different pads or areas measure something different. The one that we're really interested in is this one at the top, which measures pH. If we look here at our guide and up at the top row where it talks about our pH color change, we can see that we really hope we're going to get a nice green, because that's going to be a neutral color, and that's what we want our water to be, is just neutral. If it comes over into the blue range, it shows that our water is basic. Or over into the red or orange range, that's going to show that our water is acidic. Both are things that we don't want for our water if it's going to be healthy. So we're going to go ahead and test our first sample, which comes from just a normal Baltimore City water source. And our second sample actually comes from, again, a nearby pond. So if we bring our sample up and again compare it to our chart, we can see that we're kind of, I would say, at about a 6.5 for our Baltimore City water pH, which is pretty good. It means we're a little acidic, but for the most part, we do still have a pretty neutral water. Now, if we go ahead and look at our pond sample, and again, we're looking at that top marker. If we move it over, it actually looks like we're right around a 5. Alrighty, so we are right around a 5, which is that orangish, maybe moving into the yellow and green, but definitely I would say closest to the 5, which means that this water is fairly acidic. Now, thankfully, this water is not water that we drink, so that's good for us as humans, but again, this does have an impact on the aquatic life, like fish and frogs and things that might live in this pond. So there's something to think about if that water is being affected by the shoreline and how that health of the water is really affecting the health and the species that live inside that aquatic ecosystem. Our third sample, again, is our water sample from right here at our very own waterfront. So we will see how our waterfront water fares. Now again, our living shoreline isn't very old, so we might still be able to see a lot of room for improvement if we come back in just a couple years. This is a brand new bottled water. It's never been used before, so let's see what our pH is like in our bottled water. Now, going back to our waterfront here at Camp Woodlands, if we move it over, again, we have right between about that 6.57. So right 6.57, it might be still a little bit acidic, but compared to that pond water that probably doesn't have a living shoreline at all, it's much less acidic. So that gives us a lot of hope and a lot of promise for what we're doing. And then finally, if we go over to our bottled water, this is pretty interesting. It seems to be fairly acidic. So right now our strip test is telling us that it's a little bit higher than a 5. So with that one, I might say that this strip might be a little bit off, because usually bottled water is not that acidic. So again, with all things in science, this one just might need a double test for our bottled water. If you or your troop are interested in getting involved in the Living Shoreline Project, then email me at stem@gscm.org.